sure. Let's do this. Because I'll just steal this for another class. So I'll make a separate page here. Okay. 111, you say. Oh, yowzers. The sixth root? Mr. Kulik, that's just mean. Well, you know. All right. 111. Okay, so if I apply my de Moivre's theorem, I have the sixth root of 8 times cosine of 2 pi over 9 plus 2 pi k over 6 plus I sine, bless you, 2 pi over 9 plus 2 pi k all over 6, where k equals 0, 1, 2, 3, 4, 5, 6. Yikes! So far, so good. Oh, to 5. Yes, thank you. I would have caught that when I tried to do the sixth one, got the same answer I had previously. And they want our answers exact in trigonometric form with theta between 0 and 2 pi. All right. So if I take k equals 0 first, I'm going to have just 2 pi over 9 divided by 6, which is going to be 4 pi over 3. Is okay there? So if k equals 1, I'm going to have 2 pi over 9 plus 2 pi, so that's going to be 20 pi over 9. And if I divide by 6, that's going to be 20 over 9 times 1 over 6. That's going to be brain. Just do it the dumb way. 20 over 9 times 1 over 6. Math frac. 10 over 27. That's what I thought it was going to be, but I second guessed myself apparently. I sine 10 pi over 27. And we do k equals 2. Oops. Let's just do it on the calculator, Mr. Kulik. You're too dumb this morning to get it. I resent that. That's going to be 19 over 27. And now I'm starting to second guess that first one. I think that's supposed to be not that. I'll finish writing down this one, Mr. Kulik, before you go back and look for your mistake. You know what I mean, Enzo? Yeah. Did Mr. Kulik make a mistake? Probably. Is this going to just be 1 over 27? Probably. And now Mr. Kulik definitely is sure it is, because he can see it now. Yeah, he's dumb. And at this point, do you see the pattern happening? We're just adding 9 to the numerator each time. I'm done with the calculator here, boyos. I'm just going to use that observation to grind this the rest of the way out. How's that sound? Mr. Kulik, it's amazing. You're like some kind of math wizard. You're like the Merlin of mathing. Yeah, man. But it took me a long time to get this way. I have been training for a lot of years. And notice if I did this one more time, I'd have 55 over 27 pi, which is coterminal to 1 over 27 pi, which was the very first one I started with. Enzo, how's that feeling? If instead we asked for standard form answer, what would we do? Just grind all that crap through the calculator, right? Yuck. Anybody else? Other questions? Happy to do more. Luke.
You do 81.
81, yeah. 81 asks us to do, find the cube root of the blah, blah, blah. Leave your answer in standard form, rounded to the nearest hundredth. Okay. So I'm going to have cube root 27 times cosine of 330 plus 360 k over 3 plus I sine 330 plus 360k over 3. So when k equals 0, I get 3 times cosine 110 plus I sine 110. And look, I'm going to do the calculator part all at the end, so I'm not just like toggling back and forth. When I get k equals 1, 3 cosine, I do 330 plus 360 is 690, divided by 3 is 230, I think. And for k equals 2, I'm going to have 720 plus 330, which is 1050 divided by 3. I don't know anymore. It's going to be something. Calculator, please help. 350, I knew that. And now we're just going to go ahead and grind this out. So 3 cosine 110. Let's quick and check our mode. We are in degree mode, so we're good to roll there. And then 3 cosine of 230. And then 3 cosine of 350. Okay, so I'm going to just write those down real quick. I have negative 1.03, negative 1.93, and then 2.95. And then we'll do 3 sine 110, 3 sine 230, and then 3 sine 350. So that's going to be plus 281i minus 230i minus 0.52i. And I think that'll do her. You happy there, Lucas?
Yeah, that helps.
Yeah, of course. No problem, man. Happy to help. What else, dudes? Sorry about my penmanship. It feels like it's really bad today. I'm extraordinarily tired. Kaylee's shaking her head. It's like this is the same it looks every day, which is disheartening to me because it feels like it's real bad today. Maybe it just means it's real bad every day. Yikes. Raylan. Yeah, 94. What are we doing on that one? Find the fifth root of the indicated. Leave your answers exact in trigonometric form. That. Okay. So 94. This was a cube root. Oh, fifth root. Okay. Fifth root, 243 cosine of 5 pi over 3 plus 2 pi k over n plus I sine 5 pi over 3 plus 2 pi k over n, which is 3. I don't know why I wrote n there before. Where our k is 0, 1, 2, 3, and 4. So for k equals 0, I have 3 cosine of 5 pi over 9 plus I sine 5 pi over 9. Cool. K equals 1. 3 times cosine. So 2 pi plus 5 pi over 3 is going to be 11 pi over 3. So it becomes 11 pi over 9 when I divide by 3. And then if I add 4 pi, that's going to be 17 pi over 9. And at this point, I have myself a pattern that I'm looking at. Notice that the angles are just going up by 6 in the numerator. So I'll just grind these last couple out now that I'm certain the pattern looks good. You don't want to do it right from jump, because if you screwed the first one up, then it means like all of them are going to be wrong. So I want to do at least a couple to make sure that like, oh yeah, okay, so I didn't do, you know, I mean, if you only do 2 of them and then you do one of them wrong, like the pattern is going to be wrong for all the rest of them. So you're going to have like everything wrong afterwards, which is kind of a nightmare. So I want to do at least like 3 so I can make sure the pattern stayed the same for between both of them. So I didn't like it up too bad. So there's that. If I did one more, I'd be at 35 over 9, which I think is equivalent unit circle-wise to what we had before in the first place. Anyways, I think that's right. Let's double check. Right, everybody's. This is 94. Well, that's not the answer that I have, but is it that because the answer in here is wrong? Okay, fair enough. We'll live with it. Oh my gosh, Raylan. Ugh. Why did I write that as a 3? What it should be a 5. Oh, great googly moogly. If it looks like I'm doing stuff wrong, guys, I don't know why you just sit there and let me do it wrong.
65 on the answer sheet is also very wrong.
Well, the 165 that I did?
No, like on the answer sheet, it says that 2 to the 4th is 32.
Okay. Correct. So that's what is is this? Okay, so I add that there. That's 11 pi over 6. And this is supposed to be a 15. You dork. No, it was supposed to be a 3 because I reduced the 15. Okay, so that should be 11 pi over 15 then? Is that right? Fractions are hard in your head, dudes. That's the takeaway. It's embarrassing that your math teacher is like struggling this much, but I don't think I've got more than 3 hours of sleep continuously at any point this week. So like, it's just kind of rough in the old brain stem area. Anyways, so we're going up by 10. So I'm just going to kind of cheat now. So that's 21 pi over 15. I could reduce that, I suppose. Then I should have 31 pi over 15. That one I don't think will reduce. That's not right though, because that's already, no, maybe that is still okay. I don't even know anymore. Brainstem, you feel so oh, that's why. Okay. Yeah, that's, of course. Mr. Kulik, just like give up trying. Your life is a mess. You're a miserable failure. Stop trying to get outsmart this. Okay.
Well, be nice week.
No, I'm not feeling nice. I'm going to be real weak. Okay, I'm going to write it like this, Raylan, and not do the reducing.
Okay.
So the pattern is 6. I was adding whatever before, and it was wrong because the denominators were different.
Okay.
You get what I mean?
Yeah. No. Yeah.
You see that? So, okay. So that should be 17 pi over 15. And then we should have 23 pi over 15. This feels much, much better. I was like, that didn't look right because they were like not, you're already getting things that were bigger than 2 pi at points in there before. I was like, what is going on? And there we go. And if I add 6 again, I'm going to have 35 over 15, which is 5 pi over 15. Those are coterminal. So now I'm pretty confident I did this right. Now, there's places that I could reduce, namely just this one, though. Oops, thought I picked the color. Mostly just that one. Could go down to pi over 3.
Thank you.
You're welcome. But sometimes it's good to see your teacher make a mess out of this, so you're like, oh boy, got to make sure I don't do that. You know? That's what happens. These are the same kind of mistakes I'd expect you guys to make if you're getting careless, as Mr. Kulik was getting careless and confusing himself. The good news is that he knew that he was wrong when he started writing things. He got to a point where he was like, no, this isn't right. What's the answer supposed to be? Okay, this is not right. And you look at it, it's like, oh, maybe the answer's wrong. And you look at it somewhere, it's like, no, the answer's not wrong. I'm wrong. Maddie, you said 64 there's an issue with?
65.
65?
I think it says that the answer is like 32. Like, that's for the first, like the off. Everything else is correct. But it says that R is 32. But it's only 2 to the 4.
65. Okay. But everything else was okay?
Yeah. Yeah, everything else is good.
All right, well,
It's like 10 minutes.
yeah, we'll make a note of that. Maybe I can remember to come back and update that. Oh. Cool. Anybody else? Please say no, please say no, please say no. I've embarrassed myself enough today. It's not that it's even hard. It's just that, like, you're trying to do it with mental math, and then you're tired. And, like, fractions with mental math is sometimes kind of hard, especially when you're tired. Well, sometimes it's easy. Like, a half plus a half is easy, right?
Yeah.
But, like, 5/3 divided by 9 plus 2 pi. Like it just becomes, it's like, there's a lot of stuff going on.
Yeah, that's fun.
And then, like, if I felt fully rested, I feel like I could grind through those at a reasonable speed in my head and get them right a reasonably, 90+%, but not doing that today.
You have like 15 minutes, so like you can take a nap. This is your nap.
Alex, of course. All right. Last thing to mention here, the problem set for Sunday is 41 through 120 in the review. I know. I'm sorry. I really am. Like, that's kind of a lot of problems, isn't it? And some of them are like tedious as all get up.
Yeah, still a little bit.
I think that this is a section that maybe in the future we got to revise this problem set. Because it's just like the same stuff over and over and over again, isn't it?
Yeah, it really is the same stuff over and over.
It's just like do a different problem, but write your answer a different way.
Yeah.
Like, give me an exact answer in trigonometric form with radians, and then do it in degrees, and then do it just like, like you could probably just not ask me to do so many of these. Yeah.
I feel so smart though, because I'm using OneNote and I copied over like how there's like those rows of the same exact equation. I just copied them and I just pasted them in each.
Yeah.
For each problem, so that I don't have to write it over again every time.
Yeah, that's SMRT.
It is. Yep. Pride myself on that.
That was supposed to be a joke because notice I spelled smart wrong.
Oh shoot, you're right. You did spell it wrong.
I skipped.
I was like, no, I don't think you spelled it wrong, and then I guess I'm the